So we have a representation of functions in a table. So one thing we have to do a noticing and wondering. Well, what we're going to do here is notice that x is your input. And then f of x is your output, which again, this is really similar to just when you have your y equals 10 minus 2x. So if you're representing this, all that you do with the rule is input 1 where x is. So here, this is 10 minus 2 times 1. And that's just 10 minus 2, which is 8. So here, if I input 1.5, that's 10 minus 2 times 1.5. 2 times 1.5 is 3. So that's 10 minus 3, which is 7. Now I'm going to input 5. What happens if I input 5? So 10 minus 2 times 5. 2 times 5 is 10. So 10 minus 10 is 0. What about if you input negative 2? So 10 minus 2 times negative 2. Well, 2 times negative 2, that becomes positive 4. So 10 plus 4 is 14. So on here, we have a new function. So what if I do x to the third power? So what if I input negative 2 to the third power? Now, if I do negative 2 to the third power, that means negative 2 times negative 2 times negative 2. To evaluate that in a calculator, you have to use parentheses. So remember, when you do negatives in a calculator with powers, put parentheses around it. So here, I just do negative 2 to the third power, and I get negative 8. Here, this would be x to the third power. So we have 0 to the third power. Again, that means 0 times 0 times 0, which is 0. Here, if I input 1, 1 to the third power, or 1 times 1 times 1 is 1. And if I input 3, 3 to the third power, that means 3 times 3 times 3 is 27. So to check 3 to the third, you press 3, and then this caret key just means to the third power. And you can verify that with the calculator. So one of the noticings, x is the input, and f of x is the output. And then I also notice y is the same as f of x. So really, this is just taking our variable y and replacing it with f of x. There's no difference here with function notation. Just don't get tripped up. Just think of this as y equals 10 minus x.